In the world of modern rail power, there is a machine that feels less like a train and more like a moving power station. The Shen 24, also known as the Shenhua 24-axle locomotive, was not designed for passengers, comfort, or even speed. It was built for one purpose only: to drag the heaviest freight loads on Earth across vast industrial landscapes. With its immense size, extreme power output, and engineering choices that push the boundaries of what rail systems can tolerate, the Shen 24 stands as one of the most intimidating machines ever placed on steel tracks. But when you look closely at how this locomotive was designed and how it operates, you begin to realize that many of its most fascinating features would never be approved under today's strict international safety, environmental, and infrastructure regulations. One of the strangest aspects of the Shen 24 is its sheer physical scale. With 24 axles spread across multiple connected sections, this locomotive stretches so long that it can block entire rail yards just by sitting still. Modern rail regulations in many countries limit the maximum length and axle load of a single powered unit because of the stress it places on tracks, switches, and bridges. A machine this long and heavy would fail infrastructure approval in most passenger rail networks, not because it is poorly designed, but because it is simply too extreme for anything outside a purpose-built industrial corridor. Another feature that raises eyebrows is the incredible axle load distribution. Each axle carries an enormous amount of weight, carefully balanced to prevent the rails from bending or cracking. In modern rail systems, especially in urban and mixed-use networks, there are strict limits on how much weight can be applied to each axle. The Shen 24 operates in environments where tracks are reinforced specifically for it. If this locomotive were introduced into a standard rail network, it would be considered a rolling violation of structural safety codes. The power system itself feels almost unreal. The Shen 24 draws massive amounts of electricity from overhead lines, consuming energy at levels comparable to a small town. Today's environmental and energy efficiency regulations push rail systems toward optimized power usage and regenerative braking to reduce strain on the grid. A locomotive that pulls power at this scale would face serious regulatory challenges in countries where energy networks are shared between public transport, homes, and industry. One of the most unusual features is how the Shen 24 is controlled. Instead of operating like a traditional single locomotive, it behaves more like a coordinated system of multiple engines locked together under one command. This level of centralized control requires specialized software and communication systems. In many modern rail jurisdictions, safety laws require multiple independent control and fail-safe systems to prevent total failure if one system crashes. The idea of a single control network managing this much mass and power would raise serious concerns for regulators. Then there is the braking system, which has to stop not just the locomotive, but entire kilometers of heavy freight behind it. The sheer momentum involved means braking distances are enormous. In most modern rail networks, especially those shared with passenger trains, there are strict rules about maximum stopping distances and emergency braking performance. A train that needs such long distances to safely come to a halt would be banned from operating anywhere near public rail corridors. Another strange feature is the way the Shen 24 handles curves. Because of its length and rigid structure, it requires tracks with wide, gentle bends. Tight turns found in city rail systems or older rail networks would be impossible for this machine to navigate. Modern rail standards prioritize compatibility and flexibility. A locomotive that can only operate on specially designed routes would be considered too limited and unsafe for general use. The heat management system is another extreme design choice. The Shen 24's electrical components generate massive amounts of heat under full load. To deal with this, it uses heavy-duty cooling systems that vent large volumes of hot air into the surrounding environment. Today's environmental standards in many countries regulate thermal pollution, especially near populated or protected areas. A machine that releases this much heat would face serious environmental restrictions.